The following molecules are, and after this we have two molecules drawn and we have the options of either identical, enantiomers, diastereomers, or constitutional isomers. And so what this question is asking us to do is to compare these two molecules and determine if they are the same or if they are some sort of isomer. So the first thing that we're going to do is we're going to quickly just number the carbon chain to see if these have the same name in terms of the principal chain and where the functional groups or substituents are located. That would tell us if they are constitutional isomers or not, because constitutional isomers would be things that are connected together differently. So with this quick numbering, we can see that on both of the molecules, we have a 6 carbon atom chain, so it is a hexane chain, and that we have alcohols on carbons 3 and 4. So these are both 3,4 hexane diol. And so since that part of the name is the same, we know they're connected together the same, so they are not constitutional isomers. So what we are left trying to decide is whether or not these molecules are identical to each other or if they are some sort of stereoisomer. So I'm going to consider diastereomers first. So these would be stereoisomers that are not mirror images. And a quick glance at the two chiral carbons that we have, that's carbons 3 and 4, we can see that the stereochemistry is inverted, going from carbon 3 to carbon 3 on the second molecule, and the same thing for carbon 4. So these really do look like they are mirror images of each other. So that means that these two molecules are not diastereomers. So we are left comparing whether or not these are the same, identical, or if they are enantiomers. So enantiomers are specifically stereoisomers that are mirror images and so we might be tempted to stop here and just circle enantiomers, but that's not all there is to it. They also have to be able to not be placed one on top of the other. So they cannot be superimposed. And so again, it might look at a very quick glance that we could pick one up and put it on top of the other and that they would not line up. But what we need to look at is a little bit deeper and notice that at each of these chiral carbons, the chiral carbons are bound to the same 4 groups. They each have bonds to an ethyl group, to an alcohol, to a hydrogen, and to the same rest of the chain. And so what we're going to need to do here is to rotate these molecules. And so I'm going to spin this bond around this way because right now in this bond line formula, it is in a staggered conformation, which is not a symmetrical conformation. So what I'm doing by rotating this bond is I'm looking for a plane of symmetry. So when I rotate that bond, so I'm going to keep this left-hand side of the molecule the same. So I've still got my alcohol facing away from me. When I rotate this bond, I am rotating that 180 degrees. So I'm going to bring the alkyl chain up this way. And what that also means is that hydroxyl, which was facing out, when we flip it around 180 degrees, it's going to be pointing away from us. And now once we have it in this conformation, and this is, so we started off with a staggered conformation. We've now drawn this as an eclipsed conformation. And now in this eclipsed conformation, we can see that we have a plane of symmetry. Okay, and if we do a similar rotation on the second molecule, So I'm going to rotate the bond the same way. So again, I'm going to bring it up here. I'm going to keep that left-hand side of the molecule the same. So that hydroxyl group is going to be facing out of the plane this time. When we rotate, we're going to rotate again 180 degrees. So we're going to bring this group up. And that is going to bring this hydroxyl that was facing away from us. When we rotate it 180 degrees, it's going to be facing towards us. And again, with this molecule, we're going to be able to see a plane of symmetry. And it still may look like these would not superimpose. And indeed, if you picked this up exactly as it is and put it on top of there, then you'd have one set of alcohols pointing away and one set pointing towards you. But if you imagine you just took this and turned it over, you can see it would be the exact same molecule. And what this means is that these two molecules are what we call meso compounds. And so meso compounds contain chiral centers, but they are what we call achiral or not chiral because of an internal plane of symmetry. So because of a plane of symmetry. And so what this means is that these two molecules are actually identical. And if we wanted to finish off our name, instead of having RS in the front, we would indicate that this is a meso compound. So it would be meso 3,4-hexane diol.